Okay, this is section 5.2, double integrals over general regions. But first, let's begin. Hear, O Israel, the Lord your God, the Lord is one. You shall love the Lord your God with all your heart, with all your soul, with all your mind, and with all your strength. The second is this, love your neighbor as yourself. There's no commandment greater than these. Okay, hearts full and minds ready, let's begin. Now, we are going to start solving double integrals where we're going to have a variables in the upper and lower bounds of our integrals on the inside. So what we're going to do is we're going to solve this thing right here, and then I'm going to do it in stages, and then we're going to draw the region of integration. So first, let's do that integral. So the integral from 1 to x of 2x squared y to the negative 2 plus 2y dy, well, integrating with respect to y gives us negative 2/3 x squared y to the, nope, negative 2 x squared y to the negative 1 plus y squared from 1 to x. So then we plug in x's into our y's for the top number, and we plug in 1 into our y's for the bottom number. So plugging x's into our y's, we get negative 2 and x squared, and a y, x to the negative 1 just be x, plus x squared minus negative 2x squared, plus plugging in a 1 to the y is 1. So then, how many x squareds do we have? With 1 there, minus double negative is positive, so 3x squareds. How many x's? Just minus 2x, and then minus 1. And that is our answer there. That's the inside. So when I then integrate from 1 to 2, the integral from 1 to x of 2x squared y to the negative 2 plus 2y dy dx, well, that's just the whole inner integral is something I already did. It's 3x squared minus 2x minus 1 dx, and then I can integrate that to get x cubed minus x squared minus x from 1 to 2, plugging in 2 for everything. For all my x's is 8 minus 4 minus 2, then minus 1 minus 1 minus 1. So that's equal to 2 minus negative 1. And then double negative is positive, so it's 3. Okay, now the region of integration. And this is where something students often get mixed up with the region of integration. Because remember, there's two things going on. There is the area, like the base, and there's the height of your whatever sort of volume you're finding here. And so the region of integration is your regards to the base, not the height. So your height, that's the height. Your region of integration is related to those numbers. Okay, so this is the height of your function, of your terrain. This is your region. Okay, so the region is, I'm gonna just erase over here so I have a room here to really draw this. So when you talk about the region of integration, the 1 in x means that 1 less than equal to y less than equal to x, and the 1 and 2 means 1 less than equal to x less than equal to 2, because the 1 to 2 corresponds to the dx, the 1 to x corresponds to the dy. And so that means your region of integration is all the x and y's such that 1 less than equal to y less than equal to x, and 1 less than equal to x less than equal to 2. Okay, so how would you draw this? You can draw it with 4 lines then. The lines, when y equals 1, let's draw with a different color here. So the line when y equals 1, let's make big tick marks. So y equals, oh, I missed the tick mark. Let's just assume I got it. All right, y equals 1 and y equals x, and x is 1, x is 1, and x is 2. So that gives me this region right here, because y is here, y is greater than or equal to 1 and less than or equal to x, and x is between 1 and 2. And this is also something you can do on Desmos, if that helps you. So let me pause real quick and show you how to do that. So here, if I make 1 less than or equal to y less than or equal to x, and I make 1 less than or equal to x less than or equal to 2, then if I now say zoom in here, it's where they both overlap is where my region of integration is. So I could probably do, I wonder if I'm allowed to do and. No. So just with Desmos, you might just have to do the overlap. So with Desmos, it's the overlap. So it's fun to do more primary colors, I think. If I do like a purple, blue, if I do more like a green, orange, purple, yeah, it's the best that I can do right there. So that kind of Desmos can help show you. And so then this is only the base of the thing I'm finding the volume of. So remember that. Okay. So that finishes up the introduction and the first example.